So we have already studied regarding some substitution cipher and the types of the substitution cipher earlier. So now we'll come across another type of cipher called the transposition cipher. So we have already discussed what is a transposition cipher and how is it different from the substitution cipher here. So you know this transposition cipher is nothing but permutations of the letters in the given plain text. For example, if the given plain text is A, P, P, L, apple, if the given plain is apple, then we are just transpositioning the places here, the places of the letters here, means we are just performing the permutations of the positions here. For example, in the transposition, if I want to perform the ciphertext, then I can write in a various of manners by just interchanging the positions of the letters here. It is different from the substitution since I am not replacing A with any other letters in the English alphabet. Here I am just changing the position. For example, A may comes in the second place, P may come in the first place, this L may comes in the third place, this E may comes in the fourth place, and the second P may come in the last place here. So I am not substituting with any other letters in the English alphabet. I am just changing the positions here. Whereas in case of your substitution cipher, so it can be A can be replaced by B, P can be replaced by Q, this P also can be replaced by Q if it is a mono-alphabetic cipher, then L can be replaced by M, and E can be replaced by F here. Means I am just performing an addition of 1 as the key and performing the substitution cipher here. But in case of these transpositions, I am not doing that. I am just changing the positions here. A comes in second place. It is not restricted that I can only do in this manner. So you can do in any sort of manner, and the only thing is that you cannot add or remove any letters from the given plain text, but you can only change the positions here. This is how a transposition cipher works here. So according to the nature of the given key, the transposition cipher can be keyless. So without any key, you can perform the transposition cipher. By a given key, you can perform the transposition cipher, and a hybrid. The hybrid method is nothing but a combinations of this keyless and the key cipher here. So if you understand the working of keyless cipher and a key transposition cipher, then hybrid is the combinations of the keyless cipher and the key cipher here. So let us see one example of keyless transposition cipher. The very best example is the Ralph-N cipher. The very best example of the keyless transposition cipher is a Ralph-N cipher here. Why Ralph-N cipher? If you look at this particular diagram, we have drawn a table here consisting of 2 rows and many columns here. Okay, so how, for example, in a rail, so this particular diagram looks like a rail or a fencing, right now, or a rail track. This looks like a rail track or just like a fencing. So by the name, they have taken the name as a Ralph-N cipher here. So there is nothing underlying meaning of this Ralph-N cipher, but by just looking at the nature or the characteristics of the given figure, so they name it as the Ralph-N cipher. For example, I have given a plain text as meet me at a party. So this is a given plain text, and for a given Ralph-N cipher, the depth of the given, the depth means the number of rows will be given here. Okay, so we always term this one as the depth of the Ralph-N cipher. Depth means you may just know this one as the number of rows here. Okay, number of rows. So in this particular diagram here, we have 2 rows here. How come these 2 rows? It depends upon the depth of the given Ralph-N cipher here. If the depth is 3, then you have to make up to 3 rows here. Okay, 3 rows. And how many columns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is nothing but the number of letters in the given plain text here. How many letters are there in the given plain text? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 letters in the given plain text. So the number of columns will be 16 here. The numbers of the column is determined by the number of letters in the given plain text, and the number of rows is determined by the given depth in the relevant cipher here. So given in any questions exam, so if the question is regarding the relevant cipher, you must look what is the depth of the relevant cipher. If the depth is 2, you must draw 2 rows. If the depth is 3, you must draw 3 rows here. Then the number of columns, it is depend upon the given plain text here. How many letters are there in a given plain text? And according to that, you have to draw the number of columns here. Okay. So I have drawn the cells here already, 2 rows and 16 columns here. So how do we fill? So we write in diagonal wise manners here. In relevant cipher, we write these particular plain text letters in diagonal wise, starting from the very first cell. So I write as M, and the next letter diagonally, okay, and then the next letter diagonally here. So this comes in diagonal manner here, okay. So up to the last one, the last letters will be Y here. So we have already filled the cells with all the 16 letters here. Next, how to write the ciphertext. How to write the ciphertext means how we are doing the encryption part. We are writing a scramble ciphertext so that the third person or the third party does not understand the meaning for that. Okay. So how after writing this, after completing the cell, if you want to write the ciphertext, then you read it row wise. Okay. You read it after writing in column wise manner, you read it in row wise manner here. So if I read in row wise, M comes here, E comes here, M comes here, A comes here, and so on. After this T, again E comes here. So you have to read it this first row and then read the second row here. So this is how a ciphertext is made here. And this is for the encryption part. This is for the encryption part here. So actually if I want to do the decryption part, how actually I do it? In a decryption part, you write this one row wise and read it column wise. How actually we do here? I write column wise and then read row wise here. In column wise means I write in column wise but in diagonal manner here. Okay. I write column wise but in diagonal manner here. Here also you do the reverse part. Here I write in column wise first and then read row wise. So you do the reverse part, means you write it row wise and then read column wise. So this is the manner here. You have written row wise and then you write in the column, read in column wise. Then M, E, E, T, meet here. M, E, me here, and then so on. You will get the original plain text here. Okay. So if in exam, if they have not mentioned about the relevant cipher, and if you are asked to perform the keyless transposition cipher, okay, if the name is not given, and if they are asked to perform only the transposition cipher keyless, having given in this manner, then if the depth is given 1, 2, 3, 4, or a 4 by 4 cell is given, or any depth is given, then you have to construct the depth. If it is not, if the question is not asked regarding the relevant cipher, okay, so if you are asked only to perform the transposition cipher, keyless transposition cipher here. The depth may be given. The depth is 1, 2, 3 and 4. Okay, in this case you have constructed the 4x4 matrix and then you have to write all the letters here. So you have to write row wise. There is no certain rules here. Okay, you can means there is no certain rules. For encryption you can write row wise, okay, row wise, and then read column wise, or you can just do the reverse part. The only thing is that we should make the letter, this letter scrambled here. Okay, scrambled means not meaningful letters here, not meaningful word here. Either here by case I have written here write row wise and then read column wise, so you can do the reverse part. So if I have done this in this way, right, writing in row wise manner and reading in column wise manner, so if you do the decryption part, you will be doing the reverse part here. Okay, so write row wise means I have to write, the reverse part means column wise and then read row wise here. So in other case you can also do one thing, you can also write column wise and then you can read row wise. So there is no certain or hard and fast rule regarding the formation of these rules here in encryption, what either we should write in row wise or column wise and so on. But the only thing is that if you are doing the encryption in this manner, you have to follow the decryption in this manner here. Or if you are performing the encryption in this manner, you have to perform the decryption in the other manner here, the reverse of this one. If you write in this manner and do in this manner, then they are closely connected, so we cannot do this one. So for this one you have to follow this one here, and for this one you have to follow the other way. So in this case I have already written what is the key transposition cipher and regarding the keyless transposition cipher. So you just go through this one and understand what is the keyless transposition cipher here. So next we'll come up with the key transposition cipher.